Alright, if you're looking at problem number 1, it tells us that we have something fired off at 20 meters per second, and we know it's going to go up and it's going to come back down. So essentially what we're looking at is a one-dimensional problem where something starts here and ends here. And we always like to make a table of the quantities that we have. So our VI is 20. We know that this is under the influence of gravity, so let's just get that out of the way. 9.81 meters per second squared for gravity. In addition to that, VF, based on what we've talked about in class, you may conveniently know that our object is going to impact at the exact same speed, but let's, for the sake of argument, say that maybe we don't know this right now. Time, that's really what we're interested in. That's what the first question asks you to solve for. And then after that, delta y. Now this is something that's not explicitly told to us, but if you look at the picture, here's my initial position and there's my final position. They're both at a height of essentially 0 meters. So if I were to calculate delta y, it would be final minus initial, 0 minus 0. Delta y is just 0 here. So we have our 3 out of the 5. And if I use the formula of delta y equals VIT plus 1/2 negative g t squared, that is the key to solving for the time of flight here. So putting in 0 for delta y, 20 for VI, t is unknown, 1/2 negative 9.81 t squared. A lot of people look at this, they're like, oh well, we got a squared term, but when you multiply that out, that is negative 4.905 over there, t squared. And then what we can do is we can take that, add that term to both sides so it becomes positive over there. And we would have 4.095 t squared equals 20t. And we can get rid of that squared term because t appears on both sides. So if we divide both sides by t, now we can isolate t. 20 divided by 4.905 is going to be our answer here. And what we're going to get is, is a hair over 4 seconds. The time I get is 4.077 seconds. So let's keep track of that. There's our time of flight. Impact velocity, the next question that's asked. Off the top of our head, we may recognize that this is going to be impacting the ground just as hard, but we can prove it. We can prove it with this formula right here. And essentially, what we want to do is take a look at that formula and plug in that time there. And that'll give us our velocity at that particular time. So if I put in 20, negative 9.81, and then my time of 4.077 seconds, what we get is an answer of negative 20 meters per second. So there's our impact velocity, and we've proven that it impacts just as hard as we threw it up. Now the last question says, well, what about the maximum height? How high is this thing going to go? We have to be aware that that's a completely different time window. When this thing is moving up, it was obviously fired at that same speed, 20 meters per second. But we are considering a final velocity at a different time point. A lot of people go VF, isn't that the velocity when it's all said and done? VF is your velocity at a particular time t, and we're considering a different time here. What we should know is that at maximum height, the velocity is 0. It goes from positive to negative at that one instant in time. So it is temporarily at rest, but not for long, because it'll come back down just as soon as it made it up there. And then last thing is gravity. We still know what that is. There's our 3 out of 5, and what we can do is we can solve for delta y here. So I actually like using this expression to always solve for max height, because it does it for me in one step if I know the firing velocity here. So putting in our numbers, VF is 0 and VI is 20. And we get 2, negative 9.81 delta y. So delta y is our only unknown here. And basically, we can take that whole term, move it over there, and we can get this answer pretty quickly. When I end up solving for delta y here, I get a delta y of 20.387 meters. So that is exactly how high it went. Here's one more thing I really want to do here is I want to take a look at the time window. You may have gotten this answer using the other formulas. Remember, there is no wrong formula here when considering these problems. So if I did, let's say that different time window and used a different formula, what if I used this formula right here? We said VF is 0 up there, VI was 20, negative 9.81, and there's our time. Move that over there so it's positive, and then we'll just do a little bit of division here, and it'll be essentially 20 divided by 9.81 is going to give us our time here, which is 2.039 seconds. And what I want to really show you is that when we compare that value and that value, this is exactly half of that value there. So it's not a coincidence. It's half the time to go up and half the time to go down, essentially. And that's what we're going to find there. That's another convenient fact to know. So last thing we could do is we could use delta y equals VIT plus 1/2 negative GT squared here. And we can take that time value, plug it in there. We have our VI value, we have our G value. And I promise you that even if you use that different approach there, you'll still get this as your same answer. So that is something to be aware of in these problems.